Here we go. Our objective for today, I can solve and graph quadratic equations using intercepts and vertex. So, look at it. We're still in the same concept. We already know how to solve and graph. However, what do you notice that's different? Share with your neighbor. What's different on the objective? Yes, you'll notice that they're different colors. However, the one thing that's new for this lesson is vertex. We already used intercepts before. We already solved. We already graphed. We already know what quadratic equations are. Therefore, we don't need a Fourier model. We know what they are. We do need steps, though. Copy these down, please. It's only 7. Copy that, please. Step 1. It says, make sure the quadratic function is in y equals x squared plus bx plus c form. When you get to that point, make sure you write underneath or above it, I want you to write standard form. That's standard. Step 2, use a quadratic formula to find out the number of solutions. Step 3, use the quadratic formula, that's what QF stands for, to solve for the x value of the vertex. When you get here to vertex, everybody look up, please. Make sure you draw an arrow pointing to the Q side. And vertex means this is the minimum and or the maximum. Does everybody remember what a minimum and maximum are? Yes, that's the lowest or the highest point of a parabola. Step 4, substitute the x value of the vertex into the function to find the y value of the vertex. Once again, what is the vertex? The minimum and the maximum. Step 5, solve the equation and identify zeros, which are our roots. We know what those are, right? Step 6, plot your y-intercept, zeros, vertex, and graph your function. And step 7, sketch your line of symmetry. Copy that, and then I'll go over it. We got these steps in order for us to graph. Now, this lesson I titled it Characteristics of Quadratic Functions. We've already solved quadratic functions 4 different ways, including the square roots. Remember that easy lesson? However, we also did some graphing, but only using the intercepts. But today we need to do one more step, which is using the vertex and using the line of symmetry. So I'm going to go through each step, and I need you to get the graph paper in front of you, the one with the big graph, and at the top, I want you to copy this problem. Example 1A. The big graph, example 1A says, copy this at the top left. Example 1, solve and graph the quadratic equation using the vertex. Once again, what is that? The minimum and the maximum. So it's either the highest or the lowest point. The x-intercepts, what are those called also? Roots, zeros, or our solutions. And our y-intercept, we know how to get that from the equation, right? So we need to do all those things. However, today, I'm going to show you, and let me give you the equation, y equals x squared plus 4x minus 5. Today, we're going to do a little bit more of exploration. I'm going to show you the quadratic formula, and the quadratic formula is not only to solve for x. We can also find some other stuff in there, and I'll show you what. Okay? Did everybody copy that? Yeah. Okay? So let me get my graph in front of me, and then I'll go over this step by step. Okay. All right, I need to pay attention because this one has a lot of steps, and some of them are just to make sure that we understand what we're going to get at the end in regards to solutions. So pay attention, pens down, eyes up here. Okay, here it goes. I'm going to make some room over here at the top, and I'm going to write down my quadratic formula. And right now you're just paying attention. Check this out. X equals minus b plus minus square root b squared minus 4ac over 2a. Okay? So for today, I'm going to use two parts of this quadratic formula instead of using the whole thing to solve for x. Check this out. I'm going to use this part, look up, which is inside of the radical, inside of the root. Does everybody see that? This is what we call the discriminant. Discriminant. And what does that mean? That tells us how many solutions we're going to find at the end. Remember when we factored some quadratic equations that some couldn't be factored, and we just wrote no solutions? Remember that? Well, this is going to tell us those that don't have a solution. This is also going to tell us those that have two or those that have one, and I'll show you that in a little bit. The other piece that we're going to use from this quadratic formula is this part, the part at the beginning. Just pay attention, look up. And I call it the California piece, right here. Everybody see it? It's kind of like crooked, but it's like a little California. Do you guys see it? All right. So this piece is also going to be used today, but this will help us to find our vertex. Okay? So this one will tell us how many solutions we're going to get, and this one will help us find the vertex, which is the highest or the lowest point. Copy that, please. So that's what we're going to use. So I'm going to go over all steps. So pay attention, please, and follow along. Step 1. Make sure the equation is in standard form. Let's look at it. Is it in standard form? Yes. It's from highest to lowest degree. Okay? Step 2. Step 2 says use the quadratic formula to find out how many roots we're going to get at the end. So here we go. Pens down, eyes up here. I'm going to use this part, the discriminant. Watch. B squared minus 4AC. So not A2. B squared minus 4AC. But I'm going to substitute values from here. What is B? What is A? 1. What is C? -5. So check this out. This becomes 4 squared minus 4 times 1 times -5. What is 4 squared? 16. -4 times 1 is -4 times -5. That's positive 20. And at the end, it gives us a number which is positive 36. Positive 36. And I'm going to do that in green so you guys can see that it's a positive 36. So now what does that mean? Whenever we get a positive number, at the end, once we solve this quadratic equation, we should get 2 roots. Are we there? However, where did I get this from? From underneath the radical, right? What happens, think about this, don't say it out loud. What happens when we substitute values in here and all of a sudden we end up with a negative square root? Think about it. Thank you for thinking about it. It's no solution. So that means whenever this ends up being a negative, it's 0 roots. That means that there are no roots. Are we there so far? Yeah. However, pay attention please. Sometimes when you substitute in here, you're going to end up, instead of ending up with a positive or a negative number, you end up with a 0. When you end up with a 0, that means you will have only one solution, or one, what do we call these? Roots. Copy that, please. So let's see. Recap. Step 1, is it in standard form? Yes. Step 2, I use the discriminant from the quadratic formula to find out how many answers I'm going to get at the end. So you're saying, but Mr. Q, what happens to that positive 36? What do we do with it? Nothing. At this point, we're done with that piece. We forget about the 36. All this is telling us, it's kind of like a map. It tells you open a map to see where you're going, right? This tells you where you're going. That's telling you that we're going to find what? 2 roots at the end. Are we there? However, this next piece is important. Step 3 says, use the quadratic formula to find the x value of the vertex. So check this out. I'm going to write vertex over here, vertex. The vertex is either the highest or the lowest point, which means it's a point, which means that we need an x value and a y value. Are we there? So to find the x value, pay attention, stop writing, please. To find the x value of the vertex, I'm going to use the first part of the quadratic formula. Watch. I'm going to use this one that says x equals minus b over 2a. You guys see this piece? And we're going to find what? X. Do you see that it says x equals? Yes, that's how we find the x value of the vertex. So check this out. What was b we said? 4. So this is negative 4 over 2 times, what is a? 1. This becomes negative 4 over 2, which is negative 2. So that's my x value. That was step, hold on, before you write anything else. That was step 3. However, step 4 says substitute that value into the equation to find the value of y for the vertex. So watch. I get this equation, pay attention. I write y equals, but instead of x, what do I write? Negative 2, but open parentheses. Watch, I'm going to write it in here, negative 2 and negative 2. So let's see, I'm going to simplify this. Pay attention, please. What is negative 2 squared? 4. What is 4 times negative 2? That's negative 8. And I bring down the negative 5, the equal, and the y. The equal and the y. So let's see. Combine like terms. I get y equals 4 minus 13. I combine these two. So what is this? 4 minus 13. Negative 9. So my y value is negative 9. So let me show you what it's going to look like. The vertex is at negative 2, negative 9, which is right there. Copy that, please. So this is how we find the x value of the vertex, and this is how we find the y value of the vertex. For those of you that don't see it, check this out. I'm going to box this whole thing. And I'm going to point to the negative 2. Everybody see that? Does that help? To find the y value, I'm going to box this whole thing. And I'm going to point to the negative 9, which is my y value. This is what you need to do to find the y value of the vertex, and this is what you need to find the x value of the vertex. Got it? Okay, copy that. Okay, here we go. Once again, recap. Standard form, yes. Step 2, use the quadratic formula. Which part? The discriminant, to find out how many roots we're going to get at the end. How many did we say? 2. Step 3, use the quadratic formula, which is the first part, to find the x value of the vertex. Did we find that? Yes, that's how we found negative 2. Where did I get this from? From the quadratic formula. X equals minus b over 2a. Here it is. And I substitute the values. Step 4. Let's see. 1, 2, 3. Step 4, I substitute the value of x into the equation to find y. There it is. And that's how I find my values for the vertex. There it is. Yes. What's that? What, this? Like I said, this is just to let us know how many roots at the end. We don't do anything else with it. From there, step 5 says solve for the roots. So look at this equation. How do we solve this equation? We need to change y to what? 0. So watch. I'm going to rewrite this one right here, but instead of y, 0. 0 equals x squared plus 4x minus 5. Let's solve this one together. Which method do you want to use? You want to use the quadratic formula, completing the square, or factoring? Factoring. So from here, I open 2 parentheses, factor the first term, x and x, Power Rangers. We got 4 down here for our sum and -5 for our product. So what factors of 5 add or subtract to give us 4? 5 and -1. So this is x plus 5, x minus 1. Are we done? No. Set each one equal to 0. So I'm going to write x plus 5 equal to 0, x minus 1 equal to 0, and let's solve. -5 minus 5, x equals -5, plus 1, x equals 1, and these are my roots. X-intercepts, zeros, solutions. So let's see if we were correct with our prediction. In step 2, what did we predict? How many roots? 2. Did we end up with 2 roots? Yes. Here's 1, and here's the other. So let's plot those. Let's plot all our information. My roots are -5. Here it is. My other one is 1. Did we plot our vertex already? Yes, there it is. What's our y-intercept? Look at your equation. What's y-intercept? What is it? -5. That goes right there. Bless you. Yeah, the y-intercept is the last part of the equation, right? All right, so stop right there before we sketch our parabola. Step 7 says sketch your line of symmetry. So now check this out. Look what I'm going to do. I'm going to sketch a dotted line that's going to cross through the vertex, going straight through the x value of 2, -2. Watch. There it is. Now, some of you are asking, what does that mean, Mr. Q? Well, imagine this. Watch. Let's say you go home and you go to the mirror, and on the mirror you sketch a line that goes straight up and down through your nose. And then you're going to find out that the distance from your left eye is the same as the distance of your right eye from that line that you just drew, because we are symmetrical. So the distance from one eye is the same to the other. The distance from one ear to the nose is the same distance of the other ear to the nose. Now, that's for most of us, because some of you are kind of weird, so, you know. But other than that, it's pretty much, that's how it works. Now, check this out. What does that mean? What does that mean in regards to this? Pay attention. I drew the line of symmetry. What that means that it works the same with parabolas. Pay attention. I'm going to zoom in. Watch. Check this out. Let me move this out the way. Here's my points. These are my roots, right? My y-intercept and my vertex. Are we there? This is my line of symmetry. Look what the line of symmetry shows. The line of symmetry shows that the roots are the same distance away from it. Let's see. 1, 2, 3. Let's see this one. 1, 2, 3. That is true. That's why the parabola, I don't know if you guys noticed, it becomes like a U, right? And the same, if you drew a line straight down the middle of that parabola, the same points on one side should be the same points on the other in regards to distance from the line of symmetry. So check this out. How many steps is the y-intercept away from the line of symmetry? 2. 1, 2. So what does that tell us from this side? That there's a point 2 steps away. 1, 2. And I'm going to sketch it right there, just so that when I sketch my parabola, it's a little bit more uniform. Does everybody see that? You want me to zoom out so you guys can see it? Yeah, draw your dotted line. And so therefore, I'm going to go ahead and sketch my parabola. Let me zoom out. There he goes. I'm going to sketch that in black. Here it goes. I'm going to start over here. It goes through that point. That point. I get to my vertex, and I come back up to that point, and you draw arrows at the end. And that's how you graph a quadratic equation using the vertex the roots, the y-intercept, and one more point because of using the line of symmetry. Yeah, don't do a V because remember it curves. It's a curve. Remember the roller coaster, how I introduced these? Yeah, it's a roller coaster. So anyways, so, yes. Yes, it looks like an upside down Christmas tree, yes. Alright, so check this out. So, recap, let's see. Step 1, standard form, yes. Step 2, use the discriminant to find out how many roots you're going to get at the end. Got it. If it's a positive, it's 2. If it's a negative, it's 0. If it's a 0, it's one solution. Are we there? Next, step 3, we use the front part of the quadratic formula to find out the x value of the vertex. There it is. From there, you substitute that into the original, which is here, and that's how we get the y value of the vertex. The equation, we substitute y for 0, and then we solve whichever method. Here we use factoring. That's how we got our roots, -5 and 1. Once we have all that information, we plot our roots. There they are, -5 and 1. We plot our vertex, -2, 9, -2, 9. We plot our y-intercept, which we get from the equation. There it is, -5. I draw my line of symmetry, and then I find one more point on the other side of the y-intercept, and I sketch my parabola. So let's label this. This is called the line of symmetry. This one right here, it's called the vertex. In this case, what's another name for it if it's the lowest point? If it's the lowest point, the minimum. Very good. And this is my y-intercept. Do we need to label it? No, we got it, right? Okay. So, and that's it. So copy this next one in the back. Example number 2. Copy this one. Example 2. You don't need the instructions. Copy the equation. Y equals x squared plus 6x plus 8. And see if you can do as many steps as you can. I know we're short for time, but do as much as you can, and then I'll go over some of those steps. Go. All right, so for homework, it's found on pages what? 557, 558, numbers 2 to 32 even. Yes, turn in your homework on your way out. Have a good one, everyone. Enjoy your homework. See you guys in tutoring, if not tomorrow.